Hello, I welcome you all in this presentation on the weld bonding, and this presentation is related with the subject joining technologies for the metals. So, the one technique called weld bonding is used for joining of the metals. If you will see, this process is a combination of the two processes. One is spot welding and another is adhesive joining. So, this is this process is also termed as a variant of spot welding process, where adhesive is used for strengthening the joint. So, basically the joint produced by the spot weld is further strengthened with the use of adhesives. We will see the details of this this process combining the two processes. We know that typically spot welding is used for producing the lap joints like this by supplying the high current through the contact interfaces. High contact resistance at the interface develops heat, and this is how pressure is applied and current flows through the interface. Current I is allowed to flow for the time t, and contact resistance at the interface R helps to develop the heat through I square RT heating, and this in turn generates the this in turn produces the heat generated produces the weld nugget. So, strength of the shear strength or the tensile shear strength load carrying capacity of the spot weld in this case is governed by the area of nugget produced. So, if the area of the nugget, like say in this lap joint, if the area of nugget is small, then load carrying capacity is limited as compared to the case when the weld nugget area is increased, because it increases the shear area. So, more shear load is required for shearing the joint. So, the tensile shear load carrying capacity of the weld nugget increases. But in this configuration, typically if you will see the joint configuration, then one plate will be coming like this and another plate comes like this, and here due to the melting and then consolidation, the nugget is produced. The junction between these two plates has very low angle connection like this. So, this kind of the connection two sides, from the two sides here we have nugget. If we see in enlarged form, then we will get it like this. So, here the stress concentration at the edges where the two plates meet is found to be high. So, stress concentration is high at the junction of the two plates in both the sides, while the nugget provides the metallic connection between the sheets being joined, and this provides the required shear strength to the joint. But the presence of this stress razor due to the joint configuration poses lot of problems, especially the fatigue strength. Fatigue strength of the spot weld joints is found to be very low. Why? Because of the high stress concentration that exists at the fairing surfaces or at the joint level where the two plates meet each other. So, under this condition, since the high stress concentration exists at this location, so under the fatigue load conditions, the cracks easily initiate at these points and then they propagate. So, the fatigue strength and the fatigue life of the spot weld joints is found to be poor, and therefore lot of efforts have been made to enhance the fatigue load carrying capacity or the fatigue strength of the joint. One of the approaches here is the use of the adhesives, in combination with the spot weld nugget. So, what is done in that case? There are two approaches which are used for combining the two processes, like spot welding and the adhesive joining. So, typically what we get in weld bonding, the structure comes out to be like this. The the joint configuration is same, and first, so in this case the adhesive joint is made between the sheets being joined. This adhesive will be holding the plates together, and in addition to so it will provide some strength to the joint. So, use of the adhesive will provide some shear strength to the joint, which is further reinforced or enhanced with the use of the spot weld nugget. So, when the spot weld nugget is developed, it develops the metallic connection or the metallurgical continuity, while earlier there was just adhesive connection through the adhesive joint. So, this spot weld further increases the load carrying capacity of the joint. This combination of the adhesive joining plus spot welding is called the weld bonding. So, basically it is the combination of the adhesive joining and the spot welding. Which one will be so how this weld bond is developed? There are two approaches which are used for developing the weld bonds, and the name of these approaches is like flow in process and another is weld through process. Basically the difference is in that in which stage the adhesive is applied between the fang surfaces. So, in flow in process, what we do first, the plates are taken or sheets are taken, they are put in fang in the required configuration, and then a spot weld is made. So, first the spot weld is made, and once the nugget is formed, the adhesive is allowed to flow between the fang surfaces by the capillary action. So, adhesive is fed between the sheets being joined. So, it gets spread here and wets the surface. So, basically first what we do like this, just for a sake of clarity, what we can have, the sheets in lap joint configuration, a spot is made first and then this gap is filled in with the adhesive. So, here adhesives will be spreading in the gap between the sheets. So, first we make a spot weld and then adhesive is fed between the sheets being joined by the capillary action, so that it provides the adhesive joining in combination with the spot weld. So, this is called flow in process, wherein first a spot weld is made and thereafter adhesive is applied at the between the fang surfaces. While in case of the weld through process, in this case the adhesive is applied at the fang surfaces like this individually and then they are brought together like this. So, here we have the plates in lap joint configuration with the adhesive. So, the first step adhesive is applied, then they are brought together. In third step we develop the spot weld like this. So, when during the spot welding, when pressure is applied, current flows, it results in the two things. One is due to pressure displaces the adhesives from weld nugget area first, after that only weld nugget is formed, and the second, even if something is left and all around the weld nugget area, the heat generated decomposes or damages the adhesive all around the nugget, adhesive present in vicinity of the weld nugget. So, damages the adhesive. So, basically, so there is one the adhesive is present here, and when the spot weld is made, adhesive present in this area where a spot is being made is displaced and also thermally damaged. So, there is very much possibility that the weld nugget may have these areas, like one where our adhesive is providing the strength, 2 where we have weld nugget, and this may have the adhesives as inclusions, burn adhesives in form of the inclusions and the pores, and around that there will be a region where you will have the damaged adhesive in thermally damaged condition. So, whatever adhesive is there in thermally damaged condition, this region is known as halo, wherein we have the adhesive, but it is thermally damaged. So, thermally damaged adhesive will not be providing much strength. Definitely in this situation, that there will be two contributors to the strength, one the weld nugget and the two the adhesive which is still intact and providing the adhesive joining strength to the joint, but the area which is damaged thermally will not be providing the strength. So, if we see the top view of this kind of joint, what we will get, this is the area where we have adhesive, this is the area where we have nugget, this is the nugget area, this is where adhesive was applied, and all around this there will be one area which will be thermally damaged. This area is called halo, wherein the adhesive is damaged. So, these are the different factors. So, as far as the factors that are contributing towards the strength, that is this nugget which is providing the metallic connection, and the adhesive all around this will be providing the adhesive strength. So, relative, so the total strength of the joint will be sum of the strength due to the adhesive plus strength due to the nugget. Sum of these two will be determining the strength of the weld bond as a whole. Relative size of the weld nugget and the adhesive joint area will be affecting the total strength of the weld bonds. So, now we need to see the factors that affect the strength of the weld bonds. So, since the process is a combination of the two, this weld bonding is a combination of the two processes. So, the factors related with the both processes will be affecting the strength of the joint. So, in flow through in technique what we have seen, first the adhesive is applied, adhesive joint is made, and then a spot weld is made, and once the spot weld made, after that the joints are cured for achieving the required strength for strength for achieving the desired strength of the weld bonds. So, as far as factors affecting the strength of the weld bond, we need to see both the processes. There are two processes. One is like say spot welding and another adhesive joining. So, accordingly there will be factors associated with the both processes. So, strength of the spot weld is affected by basically the nugget area of nugget of the spot weld, and which in turn is governed by the kind of heat being generated, which is I square RT. So, basically the three factors are there here. One is the welding current, two is the welding time for which current is allowed to flow, three is the contact resistance, and from the process point of view, both the surfaces, the fin surfaces are kept under pressure, so that arcing is avoided and the consolidation can take place under pressure. So, the fourth factor is pressure. So, all these factors affect the heat generation by the way of this I square RT. Increase in time increases the heat generation, so increases the weld nugget area, which in turn increases the strength of the weld bond also. Similarly, the increase in welding current increases the heat generation, which in turn increases the weld nugget area, and therefore the strength of the weld bond is also increased. On the other hand, the pressure directly affects the contact resistance. Say when the pressure is less, there is a possibility of the arcing, but when the pressure is sufficient, so arcing is avoided, but the contact resistance is high enough. But if the further pressure is increased, the too much closeness between the asperities will be reducing the contact resistance, which in turn will be reducing the heat generation. Therefore, to match with the loss of the contact resistance or reduction in contact resistance due to increase of pressure, we must increase either current or the time for having the similar kind of the heat generation. So, the weld nugget of the same area is made. Otherwise, increase in pressure can reduce the weld nugget area, which in turn will be compromising with the strength of the weld bond. So, this is how the three the factors related with the spot welding will be affecting to the weld bond strength. So, since the process is a combination of the spot welding and adhesive joining, so say strength contribution from the spot welding is coming from the weld nugget, and the strength contribution coming from the adhesive is so strength of the adhesive joint is affected by the certain factors. These are like the surface roughness, it is part of surface preparation, basically preparation. The second is the kind of thickness of the adhesive layer, and the two factors are basically related with the curing time and curing temperature. So, effect of all these factors we will be seeing. Now, we have seen that increase in current, increase in time, increase the weld nugget areas, which in turn will be increasing the bond strength. Similarly, increase in pressure reduces the contact resistance. So, that may decrease under the identical conditions of the current and time, it may decrease the weld nugget area. So, it may adversely affect the bond strength, but there has to be an optimum pressure, so that arcing at the fin surfaces and between the sheet and the electrode can be avoided. Now, we will see in detail how the adhesive joint the factors related with the adhesive joining will be affecting to the joint strength or the adhesive joint strength, which in turn will be governing the strength of the weld bond as a whole. So, as far as this one is concerned, we will see the factors associated with the adhesive joining. Adhesive joining. First is, say, thickness of bond line or the thickness of the adhesives. So, what we can see here like this, shear strength in Newton per meter square, like say 1, 2, 3, 4 like this, and the thickness of the adhesives in mm, like say here 0.4, 0.8, 1.2, 1.6 in mm. So, what we will see that in general strength is maximum when thickness of the bond line is less, goes in like this. So, in general increase in thickness decreases the shear strength load carrying capacity of the weld joints. So, it is best when the thickness of the adhesive between the flange surfaces is minimum, because in this case the strength will be governed by the kind of bonding forces which are governing the strength of the joint. They will be determining the strength of the adhesive joint as a whole. When the thickness of the bond line is really more, in that case failure of the adhesives take place. So, the adhesives in that case the forces determining the joint strength will not be very much responsible for the strength of the joint, but the strength of the adhesive will be determining this the strength of the joint. So, in this case when the thickness of the adhesive is more, the joint strength decreases with the increase in thickness. So, it is best to have the minimum possible thickness of the bond line when it is uniformly distributed over the entire surface area. Basically, there are three mechanisms that govern the strength of the joint in case of the adhesive joining. One is mechanical interlocking, two is the electrostatic bonding, three is the chemical bonding forces. So, mechanical interlocking, basically all the surfaces have the irregularities, peaks and valleys at the surface. So, when adhesive is applied, it fills in the peaks and valleys of the surfaces, and thereby it provides the mechanical interlocking. And electrostatic bonding depends upon the how different electronegativities of the adhering materials is there, that in turn will be determining the electrostatic force bonding, and the kind of chemical interactions between the adhesive and the surface of the sheet is taking place. They will be determining the bonding force. All these three mechanisms may be overlapping, and in turn will be determining the for determination of the joint strength. So, as far as the bond line thickness is concerned, this is the effect of the thickness of the bond line or thickness of the adhesive layer over the surface over the strength of the joint or shear strength of the joint. Second one is the curing aspect, which includes the temperature as well as time. So, if we will see the combination of the time and temperature for the curing in y axis, if we have time in hours, and in x axis we have temperature in degree centigrade, then what will have, like say 100 degree, 200 degree, 300 degree, like say 150 and 200 degree centigrade, and in y axis we have 1, 2 and 3 hours. Then our strength in general for the maximum strength, you see this shaded area indicates the combination of the time and temperature for the maximum strength of adhesive joint. During this, the chemical interactions and the molecular bonding will be taking place during the curing, and so it is required to have the optimum combination of the time and temperature during the curing, so that maximum strength of the adhesive joint can be achieved. So, this shaded area indicates the kind of combination of the time and temperature required for the curing. Either side, either under curing or over curing will be adversely affecting the strength of the joint. So, now we will see one more diagram where we will be seeing the effect of the curing time and temperature on the shear strength of the joint. So, shear strength of the joint in Newton per meter square. If you will see here in y axis, if we have time, we will be using two scales basically just to show very long period of the time of the curing. So, here say it is 1, 2, 3 hours, 4, 6 and then say 1, 2, 3 and here say 20. So, here this one here up to 6 we have time in hour and thereafter time in days, like say 1 day, 2 day up to 20 days. So, what we will see that when we really work with the higher temperature in y axis we will have the same 1, 2, 3 governing the strength of the shear strength of the adhesive bond. So, here what we see basically the strength increases rapidly and thereafter it starts falling when the curing is done at high temperature. On the other hand, when curing increases the strength rapidly when it is done at 100 degree centigrade. When it is done at somewhat lower say 80 degree centigrade, curing again happens, but it takes longer time for reaching the higher strength. This is for say 50 degree centigrade curing, and then if we consider the curing at very low temperature, then it may take very long time for achieving the peak strength say 20 degree centigrade. So, with the increase in temperature, the time required for peak strength decreases. It is very say 1 or 1.5 hours at 150 and then it keeps on increasing with the increase in temperature for same strength. For example, here at 100 degree centigrade we can get the same strength after 2 hours, while at 80 degree centigrade it is 3 hours and likewise. So, at a higher temperature of the curing that same strength can be achieved at a shorter curing period. So, this is how we can say that the different factors associated with the weld bonding and adhesive joining will be affecting the shear strength of the joint. Now, we will see the advantages and the limitations of the adhesive points and the applications where these are used. So, here what we will see in case of the weld bonding, since the weld bonding is combination of the two processes. So, it overcomes the deficiencies of both the processes and provides the much better strength to the joint. So, the weld bonding offers much higher strength both static like tensile shear load carrying capacity or the dynamic or fatigue. So, fatigue strength of the of the weld bond is found to be much higher than the spot welds. So, this is one major advantage of the weld bonding over the spot welding. Static strength as well as fatigue strength of the weld bond is found to be much higher than the spot welds. Then we will see since the space between the sheets being joined is filled in by the adhesive. So, it does not allow the entry of the corrosive media between the finished surfaces, and thereby corrosion resistance is improved. So, it offers the higher corrosion resistance. At the same time, the combination of the metallic connection and the increased distribution of the stresses over a larger area of the adhesive joint, combination of these two basically increase the energy required under the impact conditions. So, high impact energy of the weld bonds as compared to the spot welds. So, this is another benefit, and the very good presence of the adhesive layer between the metallic sheets acts as a good damper. So, the damping capacity of the weld bonds for mechanical vibrations is much better than the spot welds. So, these are some of the advantages. In addition to this, we know that if we make just the adhesive joint, then it shows the tendency to creep under the static load, even under the static loading conditions, means a little shift in the position of the sheets is observed even at the constant load. So, that is termed as creep. So, the creep of the adhesive joint is reduced in case of the weld bond. So, basically weld bonding reduces the creep of the adhesives, that primarily is observed when the only adhesive is used for the purpose of developing the weld joints. So, here these were some of the advantages of the weld bonding. Now, we will see major limitation is that at a high temperature the adhesive starts disintegrating. So, mostly say above 80 degrees centigrade adhesive will start disintegrating. So, these should not be used at a high temperature. Another, in corrosive environment or in salty environment, our adhesive may disintegrate or may decompose. So, that may further damage to the adhesive joint portion of the weld bonds. So, these should not be used under those conditions, and very critical surface preparation is required to remove all impurities from the surface, and so that all degreasing impurities, oxides, adsorbed gases, moisture etc. from the finished surfaces of the sheets to be joined by the weld bonding must be removed. So, it is critical to have this proper surface preparation. So, these are the 3 or 4 the limitations, you can say, the negatives related with the adhesive related to the weld bonding. As far as the application of the weld bonding is concerned, this is mainly used under the conditions where the joint is very critical and we want to reduce the stress concentration. So, mainly for joining of the aircraft components and in development of the missiles, joining of the missile technological parts, and also it is common in the automobiles, especially for the sports bikes and the sports car. These are used means the weld bonding is used, which allows the much better the fatigue resistance as well as resistance to the corrosion. So, now I will summarize this presentation. In this presentation I will talk about the weld bonding, the factors that affect the strength of the weld bonds, and what are the advantages and the limitations of the weld bonds. Thank you for your attention.